Hey guys, before we continue on with probability, we are going to teach you guys about the fundamental counting principle. This is the first example in 12-3 in Pearson. And the fundamental counting principle pretty much says that if you have one event, and if that one event can be selected in m ways, and event 2 can be selected in n ways, then the number of ways to make both selections is pretty much m times n. So it's teaching us how to count the number of ways that event 1 and event 2 will take place. Remember that and means multiply. So then we have this taco problem. Imagine I'm having a taco party, and there are options. In each taco, you can have 4 different kinds of meats, 3 different types of cheeses, and 5 different toppings. So for my meats, I have carne asada, chicken, carnitas al pastor. For the cheeses, I have cotija, American cheese, feta cheese. And for my toppings, I have cilantro, onion, salsa verde, guacamole, and lemon. If each taco has to have one of each item, how many types of tacos can I make? Pretty much how many, different, I want to say combinations, but kind of. How many different types of tacos can I have? And in this case, based on the fundamental counting principle, there's meats, cheeses, and toppings. So I can imagine that I have a choice on meat, and I also have a choice on what cheese I want. And I also have a choice as to which topping I want. So for my meat, if I have to get a meat, in this case, I have 4 different options. Okay, so this would be like the number of options I have in each. For cheeses, I have 3 options, and for toppings, I have 5. Therefore, I can make, or I can have 60 different types of tacos. And that's pretty much the fundamental counting principle. So, Sunny Hills High School, all the phone numbers at Sunny Hills start with 714-626, and then it has the extension at the end. And so Sunny Hills purchased the rights for Fullerton, so everyone on campus has that. And the principal wants to know how many phone numbers he can create at Sunny Hills High School using that extension, So we already have the first selection of it. So really what I care about is those last 4 digits. So I'm gonna say I have digit 1. He has to pick the first digit and the second digit and the third and the fourth. So that would complete the phone number. Now, because we have digits ranging from 0 through 9, my first number, I can pick any number from 0 to 9, which means I have 10 choices. The second number, I again have the digits 0 through 9. So I still have 10 options. For my third number, 10, and for my fourth number, 10. So that means I have 10,000 possibilities. Okay? Now remember, this is pretty much like that first digit in the extension, and this represents the number of choices or options that I have for that one particular event. Okay? So these are like the 4 events. I have 4 things I have to do. Okay? All right, so now how many numbers will be there? If the number cannot contain, so now we have it cannot contain any 5, and the number must be even. So we have to consider, well, first of all, because it can't be 5, I'm not going to have 10 options anymore. But then it also mentioned this idea that it has to be even. And for a number to be even, I mean, even if I think of 3, 4, 5, it's not even until I add maybe like a 6. So for a number to be even, all I need is that the last digit needs to be divisible by 2. So I again have 4 events or tasks. I have to pick the last 4 digits of the extension. And because all I care about is the last digit to make sure that it is even, I usually like to start there. So even means that it needs to end in a 0, 2, 4, 6, or 8. Okay? At the same time, I'm saying that it cannot contain a 5. Well, 5 is not even. So for sure, just making sure that over here there's no 5s. Okay, it can be anything. It could be a 3, it could be a 4, it can be odd or even. As long as the end is even, I'm good, but it cannot be a 5. Okay, so now, because it must be even, that means I have 5 options. And instead of having 10 for these, because I can't have a 5, I can go 0, 1, 2, 3, 4, 6, 7, 8, 9. So that would be 9 options. And then multiplying these out, I would get 3,645 different phone numbers. So you can notice that once we start putting restrictions, it is not going to be the same anymore. It'll actually be less because you put restrictions on it. Okay, so California DMV decides that they need to create a new type of license plate due to the amount of cars in the state. They are going to have 7 characters, so 7 symbols. Out of those 7 characters, the first 2 have to be numbers, the next 2 have to be letters, and the last 3 have to be numbers. So together they add up to 7. So in this case, I have 7 events, 7 characters. Okay, and I have to select the first character and the second character and the third character and the fourth and the fifth and the seventh, the sixth and the seventh. So and means multiply. Remember, in this case, or we can also think of it as the fundamental counting principle, but I cannot have it with an or. I can't have 6 or 7 characters. I have to have and the 7th character. All right, before I move on, I like to label things. So the first 2 must be numbers. You can see that I like to label like my underlines. So this is a number, this is a number. The next 2 must be letters, letter, letter. And the last 3 must be numbers. Okay, because we are going from 0 through 9, that means I have 10 digits I can choose from. For the next one, I again have 10, but then I switch it up. Now I have letters. Well, there's 26 letters in the alphabet. So for the next one, I will again have 26 letters in the alphabet to choose from. And for all the other digits, I have 0 through 9 to choose from, which means there's 10 numbers to choose from. Again, remember that all these numbers up top means the number of choices. Not necessarily, I'm not necessarily picking the number 10. I'm saying that if I have to pick a number, I have 10 options or 10 choices. Together, all of these multiply to 67,600,000 different license plates that I can create. Okay. For part B, we're going to get slightly less because, well, actually not slightly less, because now we're creating some restrictions. So now what if no number or letter can be repeated? So that means I'm going to have 7 tasks. 2, 3, 4, 5, 6, 7. Again, this is going to be number, number, letter, letter, number, 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 because that's how the DMV wants it. But in this case, the numbers and the letters cannot be repeated. So once I pick a number here, he cannot repeat it. Once I pick a letter, I cannot repeat it. And because I picked these 2 numbers, I cannot repeat those 2 ever again. So for the first number, all the numbers are available, all the digits. So I have 10 digits. But out of those 10, I'm going to select 1 to be my first digit. Out of those 10, I selected 1. Which means the next one, you no longer have 10 options. Now you have 9. Because again, you can't repeat the previous. Remember, 10 was the possible number of options I had, the choices I had. And out of those 10, assuming that I selected 1 of those, now there's 9 in the pot. Okay. For letters, I haven't done any letters, so I have 26. But out of those 26, once I put a letter down here, that means the next one only has 25 options. I can't repeat the previous letter. For a number, I don't start over. I've already used 2 numbers here. So now this is 8 and 7 and 6. And together that multiplies to 19,656,000. Okay. Pause if you need to. And when you're ready, we shall move on to the backside. Okay, so again, when we have the word and means multiply, or means more. It means you're going to add. So it kind of reminds me of like the probability of this and that happening means I multiply. And then or we usually have like addition and subtraction and stuff. All right. But in this case, and means multiply or means add. So for example, it says how many odd numbers, they're putting a restriction on us, between 10 and 1,000 start and end with the same digit. So whenever I see these problems, it is best to try to picture them. If you don't write them out, you're not going to be able to set up the problem right. So starting with 10, it needs to be odd. So 10 is not going to be the first number. And it needs to start and end with the same digit. So start and end with the same digit, and it has to be odd. Well, I know that if it's odd, it has to end in an odd number. So starting with after 10, I think the first odd number would be 11. The next odd number, that where the first and the last digit are the same, is 33. The next odd number is 55, all the way to 99. And I can see that there's some sort of pattern, okay? But then when I get to 101, I don't necessarily need to go to 303. Because while 101 is odd and it starts and it ends with a different number, I can also think of 111. It is odd and it starts and ends with the same digit. Or 121. It is odd and it starts and ends in the same digit. Or 131. All the way to 191. And if I wanted to keep going, the next one, it wouldn't be the 200s. It would be like 303. And then it would go 313, 323. And hopefully you're seeing some sort of pattern here. 333. So it still starts and ends with the same digit, but now hopefully you're seeing this pattern in the middle. Whereas a 2-digit number doesn't have that, a 3-digit number is going to be slightly different. But there's still a pattern. Every 3-digit number is going to have this same pattern. If you don't trust, you can continue till you get to 999, which is previous to 1,000. Notice that I'm not going to go into the 4-digit numbers because it has to land between 10 and 1,000. So based on this, there's 2 different patterns. There's a pattern if I have a 2-digit number, or a 3-digit number. Notice that the only reason I'm splitting it is because I'm going to apply 2 different patterns. These have that pattern in the middle. These don't have that in the middle because they're just 2-digit numbers. So I'm just going to split them up so I don't miscount. Okay? Now, because I have the word or, that means I'm pretty much going to count these using a pattern. And then I'm going to count these using a pattern and add them up. Or means I'm going to add. So again, I have to pick 2 digits, or I could pick a 3-digit number. Okay, so for the 2-digit number, because it has to be odd, I know that as long as it ends in an odd, I should be okay. Okay, so I'm going to start there. Odd numbers would be something like 1, 3, 5, 7, and 9. So that means I have 5 options. And once I pick one of those odds, this one has to be the same as whatever's there. So again, this should be the same as the last number. So while I have a choice of 5 different options for the last number, it can end in a 1, 3, 5, 7, and 9, and it'll be odd. Because they need to start and end with the same digit, once I pick one of those 5s, that means I only have one option for this one, because it's got to match. You can even count them, 11, 33, so that's 11, 33, 55, 77, and 99. That's 5 numbers. 1 times 5 is 5. Okay? We're going to do something similar for this. The last digit has to be odd in order for the entire number to be odd. So again, I'm going to have 5 options. But again, the very beginning has to match. This again has to be the same as the last number. Okay, so I can end in a 1, a 3, a 5, a 7, a 9. But once I pick one of those numbers, like once I say that it's going to be a 1, the first number must match it. And then I have this middle, and that's what I've highlighted. And technically, the middle doesn't matter. It can go 0, 1, 2, 3, 4, 5, all the way to 9. So it's going to have 10 choices. So together, this is going to be 5 plus 50, which is 55. And I know what you're thinking. You're thinking, can't I just continue this and count them by myself? Yeah, but then you're not going to have time on the SAT. You're not going to have time on our test. Like, if you're sitting there and not having a strategy, and if you don't see patterns, there's always going to be some sort of pattern to help you count things, you know? It's like in elementary school, when you learn something like 70 times 20. Yeah, you could sit there and add 70 to itself 20 times. 70 plus 70 plus 70 plus 70 plus 70, 20 times. But then you learn to multiply so that you can count things faster, you know? So this is one of those that, yeah, it looks confusing, but the more you do it, the better you get at it. And it's a strategy. Just like multiplying is a strategy to help you count faster, this is a strategy. If you choose not to do it, it's the same as trying to take like the, I don't know, when do you learn to count? The second grade way out of, multiplication. So try to learn it. I know it's a struggle. It's hard to learn something, but your brain will learn it the more you repeat it. Okay, you can create new pathways. For example 5, Adele can take one of 3 buses to work, or, ooh, that's important, she can ride one of 2 trains and then walk along one of 4 different routes from the train station to her office. And how many ways can Adele go to work? So we have Adele, and she can either take the bus, but if she doesn't take the bus, she has to ride the train, but it doesn't leave her at the office because then she has to walk. So I can summarize this by saying, well, Adele can take the bus and she could totally get to work. Or, means I'm going to add, or she can also just take a train. But if she takes a train, she also has to walk. She can't just take the train or walk, So and means multiply or means add. So in this case, I'm just counting the number of ways. I'm not finding any probabilities. I'm just counting the number of ways. So I have a bus, a train, and a walkie. So my first event is bus. My first task is to take the bus. There's 3 buses. Or she can take one of 2 trains. So that means there's 2 trains to choose from. And there's 4 different paths along which she could walk. So that means there's 3 routes if she takes the bus, or there's 8 different possible routes if she takes the train and walks. So therefore, there are 11 ways for her to get from home to work. Okay? Example 6, the school offers 5 English courses, 4 math, and 4 science. How many schedules are possible if Brandon chooses a course in each subject? So my events are, well, Brandon has to pick English, and he can't just choose English or math. It says he has to take a course in each of them. So he has to take English, and he has to take math, and he has to take science. Now for English, there's 5 possibilities, so 5 choices. For math, there's 4, and for science, there's 4. And again, this is using the fundamental counting principle. This would mean that there's 80 possible schedules that he can make. This is without assuming that all these courses are offered anytime during the day. It's way crazier for schedules. All right. And the last example, 100 cards are numbered 1 to 100. How many ways are there of choosing 2 cards? So that's my tasks. I'm going to choose 2 cards. If the first card is not returned to the deck, well, we know that if we withdraw or if we don't return it, if we don't put it back, we know that the events are now dependent on each other in terms of probability. But in this case, let's go ahead and see what happens. So I have card 1. So I have to select card 1, and then I have to select card 2. For card 1, I have 100 options. But because I keep one of those 100 for my first card, I keep one of them, which means now there's 99. So that means there's 9,900 ways for me to pick up 2 cards, assuming that I take one, don't return it, and then grab another one. Right? And then the last one, if I do return it, then I would have card 1 and card 2. And this would be 100 times 100, which is 10,000 ways. You'll notice that in all of these, I did like my underlines. Whenever there's like a fundamental counting principle, I have a strategy and I have a structure. This structure should help you succeed. If you tend to just get answers, you're going to really struggle because you're not going to be able to catch where your mistake was. Like if one of these, if this one, like one of these, you made it into a 3 instead of a 4 and you don't write your work, then the answer is not going to help you figure out where you went wrong. So always take your time with these. Make sure that you're writing things out. Make sure that you're labeling the underneath of things, you know? You don't want to wing things. We've taught this for many classes, and you want to make, like, we always see that mistake. People who refuse to show work will eventually start struggling. So just take your time with it. You know, sometimes we go slow so we can go faster later on. And if you're struggling, watch this video again. Have a good one, guys.